Continuation for MYE Chemistry 2024-2025, question number 28. Which statement explains why diamond is used as drill bits in all drilling? Statement A, all bonds between the atoms are weak. This is not correct. Remember, covalent bonds are strong bonds. It is hard and it is strong covalent bond between carbons. So that is our correct statement. Letter C, it cannot conduct electricity. Diamonds cannot conduct electricity. That is correct, but that is not the reason why we use it as drill bits. And letter D, weak force between layers in a giant structure, thus it can slide over each other. So this statement is not for diamond. Instead, this is the statement for a graphite. Next, 29. Potassium oxide is an ionic compound, and silicon 4 oxide is a covalent compound. So let's try to write the chemical formula first. Potassium oxide from potassium which is potassium which is 1 positive, and oxygen which is 2 negative. We'll have the formula of K2O for ionic compound potassium oxide. While silicon oxide or silicon 4 oxide, silicon uses a 4 positive charge and oxygen has 2 negative. Therefore, the formula is SiO2, which, if you're familiar, this is one of the things that we discuss in the giant covalent structure. Now, which statement about both compound is correct? Letter A, they are highly soluble in water. So they are not correct for both. It's only correct for potassium oxide because potassium oxide is an ionic compound and ionic compounds are soluble in water. Letter B, they conduct electricity when melted. So again, this property is for ionic compounds, it's for potassium oxide only. Silicon dioxide, silicon 4 oxide cannot conduct electricity. Letter C, they are gases at room temperature. So they are not gas because both potassium oxide and silicon dioxide are solid at room temperature. And then letter D, they do not conduct electricity in solid form. So as we have mentioned, potassium oxide is an ionic compound, so it only conducts electricity when it's melted, while silicon 4 oxide is a giant covalent structure, so it means it cannot conduct electricity whether it's solid or in melted form. So the correct answer is letter D. Number 30, two statements about metals are given. Statement 1, metals contain lattice of positive ions in a sea of delocalized electrons. So that's a correct statement. Number 2, the localized electrons allow metal to conduct electricity. That's also correct. So that's why both statements are correct. Statement 31, question number 31. A student prepared a solution of copper 2 sulfate by mixing a dilute sulfuric acid with an excess of copper 2 oxide. Okay, first let's write the chemical formula for copper 2 sulfate. So just for practice. Okay, so this one uses copper, which is 2 positive, and sulfate, which is SO4, has a charge of 2 negative. Therefore, the chemical formula is copper sulfate. Copper 2 sulfate. Okay. Now let's analyze the situation. A student prepared a solution. So how does he prepare a solution of copper 2 sulfate? So he added sulfuric acid and excess of copper 2 oxide. So when they add it, it will form a solution of copper 2 sulfate. Okay. Later in term 3, term 4, we will learn more on how this is done when we study preparation of salt. But in here, we just need to identify how to make a solution, which will be the solute, which will be the solvent, and when we filter it, which will be our filtrate and our residue. So based on our setup, Again, let's identify the different parts. This is our beaker, and this is our funnel. Then inside our funnel, we have our filter paper. Then you will find a residue in the filter paper, and the liquid that will pass the filter paper is called filtrate. So we just need to identify which between sulfuric acid, copper 2 oxide, and the solution will be our residue, and so on. Okay, so solution use, again, I think the question here is asking what solvent is used. So we try to use the solvent to create the solution, which is the sulfuric acid. We didn't use water here. Then the solute, which one we added sulfuric acid? We add the copper oxide. So the copper 2 oxide is our solute. Then after we mix them, there will be an excess, right? So what will be excessed will be filtered. So when we filter it, what will be left as our residue is the copper 2 oxide. So as we have mentioned, that's our excess. And then what will be in our filtrate on this bottom part is the solution of copper 2 sulfate. So therefore our correct answer is letter C. So don't be overwhelmed with this type of question. They are using the actual solution and solute that we will be using later on. But then again, the skills that we're trying to learn here is how you will identify which is the solute, the solvent, what kind of solution will be done, and when you do the filtration. So just imagine it's a sand and water, like that. Okay. Next, question number 32. The different dyes in a sample of ink can be separated by paper chromatography. 4 dyes to be separated by paper chromatography. So for the dyes to be separated, so what is the property that we will have? Okay, so do they need to have a different density? Do they need to have a different color? Or do they need to have a different solubilities in the given solvent? Or do they need to have a different boiling point? Okay, so we all know that the answer is letter C. So the reason why they form different RF value, it's because the rate they are dissolved in the given solvent is different depending on what kind of compound or what kind of substance is used. So each pure substance has its different RF value. So it has its own rate of solubility on the given solvent. So that's why the height will be different. The one that has a different boiling points was used to separate. When we want to separate materials or mixture that has different boiling points, we use distillation. So it can be a fractional distillation or a simple distillation. If they have different density, we can try decantation, like when the oil will float on top of the water because it's less dense. When they have different colors, I think we can just do the simple separation for that. Okay. Question 33. Liquid air can be separated into gaseous element using the following separation method. Okay, so we have different gas element: nitrogen, fluorine, argon, and oxygen gas, with their different boiling points. Okay, which gas will be first collected as distillate? Okay, so remember, it will become distillate when it reach this part. So as we have mentioned in the first part of this paper, so we have here a fractional distillation because it has fractionating column. So we have a condenser, the round bottom flask, and of course our source of heat. We also have thermometer. So what we're expecting, the one in this solution, the one with the lowest boiling point is the one that will boil first and that will exit in our condenser as a distillate. So we're looking for the gas that has the lowest boiling point. So let's analyze our table. Remember, they're all in negative. Okay, so when you look for the lowest value, you need to consider that in negative value, the higher the number, the lowest the value is. Okay, so therefore, which one will has the lowest boiling point? So this is the lowest boiling point. So it means this is the first one. Nitrogen will be the first one to exit, followed by fluorine, followed by argon, and oxygen will be the last. So this one has the highest boiling point. This one has the lowest boiling point. So our answer is nitrogen.